I think today is the third session for this discussion, and so far what we have done, I think so, are modes of excretion, monotelism, urotelism. We did certain excretory structures in lower organisms, protonephridia, nephridia, Malpighian tubules, antennal glands. We did the structure of the human excretory system, a pair of kidneys, pair of ureters, bladder, urethra. The second session we went on to study the internal structure of the kidney, which is cortex and medulla. The medulla is having pyramids are apex papillae, papillae into minor calyx to major calyx, pelvis, ureter. We saw structure of nephron. Nephron is made up of glomerulus and renal tubule. The renal tubule starts from the Bowman's capsule, ends at the DCT which ultimately drains into the collecting duct. And finally, what are the types of nephrons? We have two types of nephrons. We have cortical nephrons and juxtamedullary nephrons. ठीक है? यहाँ तक discussion is clear to everybody, please? Huh? Okay. Today is a very vital and important discussion because today we are going to discuss the physiology, the process of formation of urine. Now, we will be discussing this in two parts. One part in today's lecture, the next part in the next lecture. Right? How urine is formed, we will be discussing today. But how urine gets concentrated, it will be the next part. Because ultimately, what we want is conservation of water. So maximum जितना भी हो सकता है उतना water हम लोग निकालने की कोशिश करेंगे. So the urine has to be concentrated. Okay. Now the physiology of urine formation involves three steps. Ultrafiltration, selective reabsorption, and tubular secretion. The three steps in urine formation: ultrafiltration, selective reabsorption and tubular secretion. Now before we go into the complexity and technical part, let us try and see what are these three processes. We have seen the structure last time. The afferent renal arteriole, which is a branch of the renal artery. This afferent arteriole will enter the Bowman's capsule cavity, redivide to form a mass of capillaries which is called as glomerulus, and which will reunite to leave in the form of efferent renal arteriole. Now glomerulus is a mass, bunch, tuft of capillaries. Is the glomerulus same as the normal capillary or different? I told you it is 500 times more permeable than a normal capillary. That means the number of openings would be more in the glomerulus than a normal capillary. Secondly, there is difference in the diameter of afferent and efferent. The afferent has a larger diameter than the efferent. Now that leads to creating a pressure in the glomerulus because successively the diameter is going on reducing. So the pressure by which the blood needs to flow will gradually increase. And under the force of this pressure, you have filtration occurring. So this is ultrafiltration. This process is ultrafiltration. So ultrafiltration is purely a physical process under the influence of pressure. और ये pressure create कैसा होता है? Due to the difference in डायमीटर ऑफ एफरेंट एंड इफरेंट, उसकी वजह से प्रेशर क्रिएट हो रहा है. ठीक है. सेकेंडली, when filtration is occurring because of pressure, my question is, will this filtrate or will this filtration be selective or non-selective in nature? Non-selective. प्रेशर में आप सिलेक्ट नहीं कर सकते, जो हाथ पे आया वो, isn't it? प्रेशर में आप सिलेक्ट नहीं कर सकते, जो हाथ में आया वो. Now because of this we have two issues. See, objective क्या है अपना? To drive out urea and to save water. Are these the two objectives? Okay. Now the two issues that arise out of ultrafiltration is the useful substances are lost. Useful substance like water, useful substance like glucose, useful substance like amino acids, useful substance like vitamins, blood में से filter होके आ जाएंगे Bowman's capsule में. Can we afford to lose these kind of substances? No, no way we can afford to lose these substances. And the second issue which arises that urea बाहर जाना चाहिए था, but the urea will escape filtration and go into the efferent. If it is non-selective, are these two possibilities there? Isn't it? Now, do we need to rectify these two? So, whatever useful substances are lost in the filtrate, they will have to be taken back into blood. But selectively. So, I will selectively take glucose, I will selectively take amino acids, selectively take vitamins, back into my body, back into the blood. Body का मतलब blood. So this step is called as selective reabsorption. This is selective reabsorption. At the same time, the urea which has escaped, oh, I need to dump this urea back into the urine now. So what is this structure? Are these peritubular capillaries? So the tubule will have to secrete the urea back to the tubule, right? That is why the process is called as tubular secretion. So will step number 2 and step number 3 rectify these two issues? See, the direction of flow is very important. जब reabsorption हो रहा है, that flow is from tubule to capillary. And when it is tubular secretion, it is from capillary to tubule. Clear, please? So 3 steps: ultrafiltration, purely because of pressure; selective reabsorption, whatever useful material has been lost will be selectively taken back; third step, tubular secretion, whatever waste has escaped, right? Ammonia ho, urea ho, H plus ho, K plus ho, whatever it is, all has to be dumped back into the urine. And then you will have final urine going out. So at least outline अपने को समझ में आया कि what is the outline of this process, right? Now we can go into the basic mechanism, details of this mechanism. Okay, great. Urine formation involves 3 main processes, namely glomerular filtration, which is nothing but ultrafiltration, selective reabsorption, and tubular secretion that take place in different parts of the nephron. So your ultrafiltration is going to occur in the Malpighian body. I hope you know what's the Malpighian body. The glomerulus and Bowman's capsule put together is the Malpighian body. Your selective reabsorption will occur in PCD-DCD, and the tubular secretion has to come from the reverse side. So are these all occurring in different areas now? In different parts of the nephron. Now first is glomerular filtration. Now glomerular filtration, obviously, did we identify the filtration membrane last time? Right? Just a very quick recap. Bowman's capsule, I hope you remember, please. Two layers, outer and inner. The inner has got specialized cells called as podocytes, right? The afferent arteriole dividing, redividing, right? So this is afferent, this is efferent, right? So do we have the glomerular capillary and the inner wall in close contact? The glomerular capillary, let's say this is the wall of the glomerular capillary, will it have multiple openings? The number of pores are going to be more, so this is the glomerular capillary. उसके बाजू में होगा अपना basement membrane. Why do we require a basement membrane? Because epithelium is always resting on a basement membrane. And this is endothelium. That means it is nothing but squamous epithelium. And on the other side, we're going to have the podocyte. The podocyte with the feet-like processes known as pedicels. And what are the gaps called as? Filtration slits. ठीक है ना? Is this the structure of the filtration membrane? Yes, please.
The permeability of basement membrane will be the same as
Yes.
glomerular.
ये नहीं, थोड़ा सा कम है, उसके उतना नहीं, ठीक है? But since it's a mesh-like structure, everything passes through. So blood is flowing through glomerulus. Is this blood under pressure? Is this blood under pressure? So under the force of this pressure, filtration is occurring through this membrane. Okay. So glomerular filtration का first point. The first step in urine formation is the filtration of blood, which is carried out by glomerulus, is called as glomerular filtration. I told